Okay, so this is problem 3, which is kind of the first kind of difficult problem in the section. So it says find the critical points for the function. And I'm just going to start off and just do that immediately and not read the rest of the problem. So to find critical points, I know I need to take the derivative. So g prime of x. And I'm using the power rule. So 1/4 times 4 is just 1. Let's get x to the third. Plus, bring down the 3, I get 6x. 3 minus 2 is 1. 3 minus 1 is 2. My bad. And then 8x. Cool. So this derivative is a polynomial, so it's going to be defined everywhere. So I'll just set it equal to 0 and solve. Now I would do that by factoring. I'll pull out just a single x. And then I'm going to factor this quadratic also. Let's see. So 8 factors to 2 and 4, which actually adds to 6, so that'll work. All right, now since I've got 3 things when they multiply to equal 0, that gives me x equals 0 as a solution, -2 and -4. So then these are my critical points that I'll use to break up the x-axis. So -4, -2, and 0. So these values are my critical points. And that gives me a couple intervals that I can work with. So my first interval, -infinity. Oh, I'm sorry, I should have read the rest of the problem to you. Okay, it says, then break up the domain into intervals and decide if the graph is increasing or decreasing in each interval. So I'm going to start with this interval here. And so a value between -infinity and -4, -5 would work. So I'll plug that into my original equation. And I find that it's easier to plug it into this derivative here than it is to plug it into the top derivative. They're all the same, it's just, different ways to write the same thing. But if I plug it into this bottom one, it makes the math a little bit easier to do in my head. So f prime of 5 would be, of -5, is -5 times -5 plus 2 is -3. And then -5 plus 4 is -1. All right, so I've got a negative times a negative times a negative, or a negative value. I don't actually need to figure out exactly what negative value it is, because all I need to know is that it's negative on this starred interval here. So that would tell me that it's decreasing. So on the interval from -infinity to -4, I know it's decreasing. Okay, so I'll move to my next interval. And I need to pick a value on that interval. I'm going to pick -3. It's a nice whole number. So plugging it into the derivative, that would be -3 times -3 plus 2, -1. -3 plus 4 is a +1. So that's a negative times a negative is positive. So it's increasing on my interval. So I'll put that down here. -4 to -2, it's increasing. And I'll move on to the next interval. So a number on that interval between -2 and 0 would be 1. So plugging that in, that would be 1 times, let's see, 1 plus 2 is 3, times 1 plus 4 is 5. Oh, my bad. I meant -1, right? -2 and 0. That's not going to work. Let's try that again. Okay, so that would be -1 times -1 plus 2 is 1 times -1 plus 4 is 3. It's like a negative number. So that tells me it's decreasing on this interval. So that would be -2 to 0. And we're almost done. One last interval to do. So this last one over here is a pretty big interval. I'm going to choose 1. That would be 1 times 3 times 5, which is positive, which tells me it's increasing. So I'll put that down here. So there's a lot of steps to this problem, and it takes a lot of understanding to really get what we're doing. So feel free to ask questions on the discussion board. Please feel confident in doing that because you're not the only one who has questions.